Hello everyone. So in the last class we saw what do we mean by roots of quadratic equation. Continuing with that discussion, for a quadratic equation I can say it has a degree of 2. So with this degree we cannot expect to have more than 2 roots. We can have at most 2 roots, 0, 1 or 2. And talking about roots, I would like to clarify number of roots are same as degree. So we can always say that we have 2 roots for a quadratic equation. Now the question arises, what if it does not have a root? Or what if it has only one root? Like as you have studied in schools. So roots are again classified as real and imaginary. And real roots I call zeros. So as we saw in polynomials, zeros are, what do we mean by zeros? If this is a quadratic equation, curve of a quadratic equation, this point and this point, this is y-axis, this is x-axis, this is origin, and these 2 points give me the intersection of this curve with the x-axis. So for equation of the form y equal to ax square plus bx plus c, if this is the curve, then at these 2 values of x, this polynomial value is 0, because this curve gives me the value of y. If this curve is in this location, at this point the value is negative, while at this point it is positive. So for any quadratic equation, what I mean by zeros is the point of intersection of the curve with the x-axis. And these are known as the real zeros because this is real axis. So if it does not intersect, like if it is of the form this type, where it does not touches the x-axis, we have 2 roots again, but both are complex. Clear? So now let's take a look on how do we find these roots. We can't just make guesses and find out the roots, right? So we'll have to devise some method so that we can find solutions of the quadratic equation. Solutions means roots. So to find roots, we have 3 methods. The first method is factorization. As you must have read in the last class is that means 9th and 8th. Second is by completing the square. And the third method, it is the formula method. Let's say quadratic formula, applying the quadratic formula. For all objective type questions, we will be using this quadratic formula because it's the easiest one. What do we mean by factorization? Let's come to that point. Factorization basically means making factors. Right. If I factorize 36, so what can I write? 1 into 36. I can write 2 into 18. I can write 3 into 12. I can write 4 into 9. I can write 6 into 6, and then again it gets repeated. So what are these? These are all the factors of 36. Clear? So if I have one expression, it is multiplied by another expression. So I'll get a polynomial, and I can say these 2 are factors of these 2 are factors of this polynomial. Similar cases, arise in this quadratic equation chapter. Like if I take up the last example that we saw, x square plus 3x plus 2 equals to 0. So I told you that x equals to minus 1 and x equals to minus 2. They satisfy this equation and thus are roots of this equation. Let's see. X plus 1 into x plus 2. Let's multiply these. What I'll get? X into x, I get x square. X into 2, I get 2x. X into 1, I get x, plus 2 into 1, I get 2. So on adding the like terms, I get x square plus 3x plus 2. And this is same as this one. So going in this direction from the polynomial towards the factors, this method is known as factorization. So now how do we do this factorization? So for any quadratic equation, let's say 9x square minus 3x minus 2, I have a quadratic equation. So what do I need to do is, I'll compare this with something of the form x minus a into x minus b, because in the end I have to make two factors like this so that I can equate each one of them to 0 to find at what value of x I am getting the value of this polynomial as 0. Right? So what I get on solving this, I get x square, x into x, minus ax when I multiply a with x. Then I get minus b into x, and in the last minus b into minus a. So on simplifying this, I get x square minus a plus bx plus ab. This much is clear. Let's compare this with what? With this equation. So what I get? If I divide this equation by 9, let's divide this equation by 9. I get x square minus 1 by 3 x minus 2 by 9. Is this clear? So when I compare, I get a plus b as 1 by 3, because minus of a plus b here and minus 1 by 3 here, coefficient of x, they must be equal. And I get ab as this plus ab and this minus 2 by 9. Is this clear? So I can say sum of the roots a and b are what? Roots is 1 by 3 and product is minus 2 by 9. And if we apply our factorization method of what we learnt in class 8th or 9th. So if I have to factorize this, what I'll do is, I'll split the middle term. So in middle term splitting, what we do? We multiply this with this. So we get 9 into 2 as 18, or I can say minus 18. This one is clear. I get 9 into 2 is minus 18. So if I split minus 18 into two factors, what I get, and this should be the sum. This should be the sum. So I get 6 and 3. If I take minus 6 and plus 3 and I split this as 9x square minus 6x plus 3x minus 2. I can split this, right? Minus 6x and plus 3x becomes minus 3x. Let's take this example again so that you understand it better. The equation what I had was 9x square minus 3x minus 2 equals to 0. This was my equation. So in order to factorize this, what I have to do is I have to split this middle term. Middle term is the one which has x as its variable. How do I have to split this? Such that, let's say I have to split it in the form a and b. So a into b, this should become equal to 9 into minus 2, or I can say minus 18. This much is clear. I have to split this minus 3 in a and b such that a into b becomes minus 18. So if multiplication of two numbers is negative, I can say one number must be negative and one number must be positive. The product of two factors a into b, then a must be negative and b must be positive. And as this 3x is basically sum of a and b, so the negative number must be greater because I am getting a negative output finally. So the sum of these two, if sum of these two is negative, that means the bigger number is negative. So let's take up the factors of 18. 1 and 18. Can I get 3 from 1 and 18? 1 plus 18 is 19, 1 minus 18 is minus 17, 18 minus 1 is 17. I can't get it. 2 and 9. So 2 plus 9 is 11, 2 minus 9 is 7. So I can't get 3 again. 3 and 6. 6 plus 3 is 9, but 6 minus 3 is 3. So I am getting my factor as 3. 6 plus 3, 9. That is not there. It's not in the sum. 3 minus 6 is 3. It's there with a negative sign. That means 6 must have the negative sign and 3 must have the positive sign. This much is clear. So I can split it like 9x square. Now I have 6 as the negative sign. So minus 6x plus 3x minus 2 equals to 0. So I have split this minus 3x in the form this. You can add them and you will see this is same as minus 3x. Now as we know, if in addition form, if we have two terms, let's say a into b plus a into c, as you learned in the 7th class or 8th class, right? Rational numbers. If in some addition we have two terms and we have one term common, so we can take this a common and write it as a into b plus c. The associativity law. Clear? So like this only I am doing in this equation. In 9x square and in 6x, what I have common is 3. Because 3 is a factor of 9 as well as it is a factor of 6. 3 being a factor of 9 and 6, so I can write 3. And x is also there common because this is x square, x into x, and here we have x. So I take out 3x. Now divide 9x square by 3x, we get 3x. When we divide 9x square by 3x, what we get is 3x. Minus, when we divide 6x by 3x, we get 2. Plus 3x minus 2 is as it is. And it is 0. I can write 1 here. So that I just not miss out 3x plus 1. Now in these two terms, what I have common is 3x minus 2. So I'll take this term common. What I am left it with, in this term I am left with 3x. And in this term I am left with 1. So I get 3x minus 2 into 3x plus 1. What I get is 0. So either this term is 0 or this term is 0. Either the first one or the second one. Any one of them is 0. So I get, from first I get x equals to 2 by 3. And from second I get x equals to minus 1 by 3. Right? And as you saw in the previous slide, what is the sum? The sum is 1 by 3. 2 by 3 minus 1 by 3. What we get? 1 by 3. What is the product? Minus 2 by 9. See the product here? 2 by 3 into minus 1 by 3. What we get? Minus 2 by 9. So this is how we factorize. This is clear. I'll just repeat again. We have to factorize this polynomial or this quadratic equation. So in the middle term, what we do, we try to express this as sum of two numbers, a plus b, such that this a and b, the product of a and b is the product of the first term, coefficient of the first term, that is the highest power, and the constant term. 9 into minus 2. I get minus 18. So now I have to split this term in two terms, a and b. Now being minus 18, product being the minus 18, I must have one term negative and one term positive. If one term is negative, one term is positive, then its sum might be negative, might be positive, depending on whose magnitude is greater. So we see here, the sum is negative. That means we have to find two numbers such that the negative one is greater. We'll see that later. First what we do is factorize 18. We get 1 and 18. So the sum of 1 and 18 is 19. And difference is 17. I am not getting 19 nor 17 here. Next we see 2 and 9. So in 2 and 9, 2 plus 9 is 11. While 2 minus 9 is 7. So do we have 11 or 7 here? No. This is also not the case. Then we come to 3 and 6. 6 plus 3 is 9. But 6 minus 3 is 3. I am getting 3 here. So I can write minus will be associated with 6 and plus will be associated with 3. So I rewrite it as 9x square minus 6x plus 3x minus 2. Clear? And then I take 3x common from first two terms. What I am left with 3x minus 2 plus 1 common, I get 3x minus 2. Then I take 3x minus 2 common, I get 3x plus 1. Then I individually make it 0. Is this clear? Let's take up another example with irrational coefficients. Root 3x square plus 10x plus 7 root 3 equals to 0. Now we have learnt in last class, irrational into irrational, it might be irrational or rational. Remember that? Same is the case with addition. So we can't say that this term is made up of rational only or irrational only or anything of that sort. Let's see. We have to split this in two terms, A and B, such that A into B, I have to split this in A plus B, such that A into B is what? Root 3 into 7 root 3. Clear? So what I get here? 21. But note in this type of questions, if I am multiplying two numbers with irrational coefficients, then addition of them should have a root 3 sign. or not? Let's see. Now we have to split 21 in such a manner that we get sum as 10. This is positive, product is positive, so of course both numbers must be positive or both numbers must be negative, but the sum is positive, hence both are positive. 1 and 21 gives me 22. 2, I don't get any natural number. 3 and 7, sum is 10, so I get my two numbers. I can rewrite this as root 3 x square plus 3x plus 7x plus 7 root 3 equals to 0. Is it clear? From these two, I get root 3, a common factor of 3 and root 3, and x. So I take out root 3x, I get x plus root 3 inside. Plus I take 7 common, I get x plus root 3 again inside. Now taking out x plus root 3 common, I get root 3 x plus 7. Putting this 0 and putting this 0. What I'll get? I get x equals to minus root 3 and x equals to minus 7 by root 3. Now we multiply these two. What I get? If I multiply these two quantities, I get 7. This is x1, this is x2. I get x1 into x2 as 7. And you multiply this and this. Sorry. You divide 7 root 3 by root 3. You get again 7. We will see in the next class that product of two roots, I can say it as c by a. For the equation ax square plus bx plus c equals to 0. If this is the equation, so I can say c by a is the product of roots. This we'll see in the next class. Or we just saw in the beginning when we compared our coefficients. When we compared our coefficients, so we saw a plus b. So a plus b, this was the sum of the roots. And this if we compared with this. And this is a into b. So at the when our coefficient of the highest term is 1, we get minus of a plus b in the second or the middle term and ab in the last term. We'll see it in the next class properly. And what I can say x1 plus x2 as, let's add these up. So minus root 3 minus 7 by root 3. I get it minus 3 minus 7 by root 3. Or I get it minus 10 by root 3. Right? Can I write this as minus b by a for this equation? Isn't it same? It's same, right? So just remember these 2 points, that product of roots is c by a and sum of roots is minus b by a. Rest of the part we'll see in the next class. Thank you.